So now let's talk about slope-intercept form. Now you may have seen this term before. You might have seen it also called something like function form. Okay, and these are very similar to each other. We'll talk about the differences later. But slope-intercept form and function form, the main thing about them is that you have y equal on the side by itself. And what this allows you to do is whatever is hanging out with x, okay, x, our input, whatever number we pick to be x, we can do the math and very quickly get an output of y, okay? And so this very easily allows us to get numbers out when we're given conditions. So the standard, now when it says function form, this is the function form of a line. Functions can be different things besides lines, and they will be in different formats. But when it comes to the function form of a line, it takes on the form y equals mx plus b. Now m, we learned in a previous video, means slope. And b means the y-intercept. So y and x will stay y and x when we have it in our form, but the m and the b will be numbers whenever we see it. Now you might have some problems where you have to find m and b, but those are generally going to be numbers. So what does that mean as far as figuring out the slope and y-intercept of a function? Well, on many of them, they will be written to where it's very obvious. For instance, if I have y equals, what a ridiculous color to use, Rick. Why would you do that? I apologize, everyone. Let's go to a darker color and actually use a pencil instead of the rectangle tool. Isn't that better? Okay. Y equals 5x minus 2. Well, if I am given this, that tells me that the slope is 5 and the y-intercept is negative 2. Okay? So I could use that information to graph, and we'll have a video later that shows you that, but those pieces of information would tell me what I need to know as far as the y-intercept and the slope. It also might be a fraction. You might get negative 2/3 x plus 1/2. And that tells me the slope is negative 2/3. And the y-intercept, that didn't draw well, is 1/2. Okay, notice again that the y is on a side by itself. That is very important for us. We need that. In fact, what we're going to talk about now is what happens when that's not the case. So let's say that I'm given 2x minus 4y equals 8. I can't tell by looking at this what the slope is. What I need to do is change it into the slope-intercept form. So I need to get this y by itself. And the easiest way to do that is to get rid of things furthest away from y first and then move closer to y. So in this case, the 2x is the thing that's furthest away. And I can't do those separately. I need to treat them the same. So I'm going to subtract 2x from both sides. And I'm going to get negative 4y, because this negative is with the 4, not with the 2. Negative 4y equals, and I can't combine 8 and negative 2x, so they're going to stay separate. And I'm going to put the x in front because that's the form. Okay? Well, now what do I have? Well, I've got this negative 4 hanging out with the y that I could really get rid of. It'd be nice. So I'm going to move it up here. And then I'm going to continue. I'm going to divide by this negative 4. Now, when I divide to get y by itself, I don't just do it to one of the numbers. This entire thing is divided by -4, which means that the -2 is divided and the 8 is divided. It's kind of like a commutative property of division. Okay, so -2 divided by -4 gives me 1/2, and that's going to stay hanging out with my x. And 8 divided by -4 is going to give me the -2. So now this equation, I can see in its new format that my slope is 1/2 and my y-intercept is -2. And so you can use this format to more easily graph functions and lines, and I'm going to show you how to do that in another video.